Basically, stability is a property of equilibrium state. Equilibrium we always mean to mention when the body is at rest. No, equilibrium definition is also equally applicable for bodies are in motion also. We are familiar with the most familiar example with regard to equilibrium is bodies are at rest only. We don't connect it to the bodies are in motion. So equilibrium can be, bodies are said to be in equilibrium when the body is at rest or when the body is in with uniform motion. These two things are applicable. Write that point. Now, to explain is there are various types of equilibrium. Stable equilibrium. Have you heard about this? Unstable. Simple thing, unstable equilibrium. Neutral. So situation is this. Suppose if you take a geometry, a cup, a bob in a cup, we call, let's say. Now look at this case. Initially, right now, originally it is at what? It is in the equilibrium position. This is also in the equilibrium position. Suppose if you take up this surface, so all of them are in the equilibrium position initially, depending on the configuration. Now look at now. We have to give a meaning for this particular stable equilibrium configuration, unstable equilibrium and neutral equilibrium. Now comment on this. When do you, which situation you claim it to be stable equilibrium? Is it in equilibrium position or not initially? This, now if you create a disturbance and take it to this particular position, and what will happen? Look at the forces, weight, mg, w. When you resolve the force, there is a component of w sine theta in this direction will be acting. There is a component of w cos theta would be acting this way. This w sine theta force is, that is the reason that it is trying to. So nobody is trying to pull it back. It will show the tendency to return to initial equilibrium position on its own. That has to be created for the aircraft also. So here what force component that is trying to pull the bob towards equilibrium position? W sine theta. W, that is generated because of this configuration. Pull it here, it will come back because it will not remain there. That doesn't mean that it should remain at equilibrium position immediately. So this particular movement towards equilibrium position, one is disturbed, is called tendency. Then it is because it will remain suddenly at the equilibrium position. No, it will again, because of inertia, it will go back to this side, and again W sin theta will be in this direction. It will try to move. So this kind of action, if it shows up, that is called tendency. The system is stable equilibrium or not? If you look at this, so finally it will remain at the equilibrium position over a period of time. That we are not talking about. That will have, that is stable also. There are two things we should talk about with regard to stability. Let me explain this. Now what actually you have to think about, this particular bob has a tendency to return to initial equilibrium position, and do you think it happens suddenly or it happens over a period of time? It happens over, so there are two things you have to classify. First one is tendency to return to equilibrium position, and finally it will remain at the equilibrium position over a period of time. There are two things you have to now understand clearly. Otherwise, it's the stability types I will tell you. So, with regard to stability, what are the two types? Tendency. towards returning, tendency towards returning, initial equilibrium position. Second is finally it remains at initial equilibrium position. Please understand the difference between them and tell me. Equilibrium position, what should I add here? Over a period of time. I segregated this action into two. Usually we look at this action as one action, but I divided this into two actions, two activities. Understand this very clearly. Okay, that I get back to this point a little later. Here, come back here. This particular surface is unstable equilibrium because once it is disturbed, it moves away from the equilibrium position. It will not have any tendency to return to its equilibrium position. But is it having equilibrium position? The system equilibrium but unstable. Unstable means it will not have any tendency to return to initial equilibrium position. But initially it is at equilibrium. People miss this point. Always say that unstable. Unstable what? Unstable equilibrium position. Isn't it? People always say it is stable. Stable means what stable? Stable equilibrium. Please understand language because everybody is missing the original flavor. Various forms of equilibrium. This particular configuration is stable equilibrium. This particular configuration is equilibrium but unstable. It is unstable. One position we can manage to keep the object in an equilibrium position. But other surfaces, it goes away from the unstable means what? Goes away from the initial equilibrium position, never show up any tendency to return to equilibrium initial position called unstable. That is the meaning of stable and unstable. Okay. What is this kind of configuration? Once it is disturbed, it moves away from initial equilibrium position but occupies a new equilibrium position. Attaining new equilibrium position once it has been disturbed is called neutral equilibrium. Here it will never attain any equilibrium on this surface. On this surface it will attain, but original equilibrium position it will not attain, but it will attain once the disturbances have been, once it has been disturbed, new equilibrium position it will attain. So same thing, this flat surface is among the various forms of equilibrium, this surface represents what type of equilibrium? Neutral equilibrium. This is position neutral equilibrium. So airplane, now connect the whole discussion with to the aircraft. How do you connect the whole discussion of stable equilibrium, unstable equilibrium, neutral equilibrium with regard to aeroplane? I will connect now. Initially equilibrium, right? Suppose you are designing, because three people are designing. There are three categories. That batch, my design, your design and your design. Three designs. So I first of all write my design. So let's see this particular one. Now here it is completely angle of attack. This particular angle of attack where aircraft is in motion, because initially it is static, body at rest, body is in motion. Two examples, because aeroplane is body at aeroplane is at rest or it's in the hangar or the airport, there is nothing to study about it. Aeroplane has to be operated. Then you talk about this. Then aeroplane, what is the equilibrium state of balance for moving objects in motion? It should be in uniform motion. It should be in uniform motion. Uniform motion is possible for an aircraft under what conditions? We have already seen this. Steady level flight when as long as lift and is balanced by the weight and drag is balanced by the thrust that it is producing, then it will maintain uniform velocity. Okay. Let's say initially at one particular angle of attack we set at an altitude, certain velocity is fixed. So these things are attained. So this particular aeroplane as of now is at equilibrium position. That equilibrium position is not a position, it is moving. It's not occupying a seat like you. Angle of attack should be referred. Here we refer to the position, here we have to refer to the angle of attack. Angle of attack should be referred in the place of position here. So equilibrium angle of attack, it is now oriented, it is flying at equilibrium. It is flying at equilibrium angle of attack means what? This is what we never discuss. Angle of attack only we talk about. Angle of attack where aeroplane is traveling with uniform velocity, wherein lift and W, where it is in steady level mode. Then that particular angle of attack is equilibrium angle of attack. Once it undergoes a disturbance, so I call this alpha as equilibrium angle of attack, right? Equilibrium position.